Good morning, everyone, and thanks for having me here in Exeter. Beautiful town. I arrived yesterday. It's quite hilly. It's good for my health, I suppose. I will talk about my challenges when I work with data at the corporation and as well outside that as well, trying to build interactive relationships. And it's very much all about trying to work with people to change and the challenges around that. So I'm using here as well a new technology. I'm not using PowerPoint or Keypoint. I've got my slides online. They're all in HTML5, so if you're lucky, they will all work, and they have some interactive elements as well. Let's see. So that means as well, later on I will show you the links so you can download them or watch them on your computer as well. So that was the abstract I put forward to Steve. And I said, I suppose most of you are statisticians, I take it. So how many statisticians do we have here? Okay, quite a fair bit. So there are few human beings as well. Superb. I'm a mathematician, not a statistician. I will tell you a little bit about that as well in a minute and why I think they're actually quite different. And data is often used, and certainly in my work as well, is to initiate change. And statistical analysis is absolutely fantastic for doing that. It's about testing ideas and challenging our thinking. And yet, it is often quite difficult to get this across to people who have less of a numerical background. So we developed at Lloyds quite a few tools to make it easier. And some of these tools I will show you today. This talk will change your life. Trust me, really. I mean, that's basically the aim of any presenter, I suppose. Otherwise, why would you listen? If it doesn't really initiate a little bit of change. So you will have a full day of marketing. That's really what we're trying to do here, all of us who will present. So trust me. And that's really important. If you don't trust me, you think, oh, that's all bollocks. Go away. So it's not just about the data, but as well it's about building trusted relationship so people believe you. Because I'm working quite closely with data and as well with colleagues, but I know as well, if I don't trust these colleagues, I can't trust this data. So I need to build up trust. And trust leads me to another comment from Karl Jaspers, a philosopher. I think he was born in Germany and died in the late 60s. And his philosophy was about communication and what actually connects us. And he says the truth is what connects us. And the truth is different for each of us. We have a different perception of what we think is right and what is wrong. And I think for statisticians, they have quite a different culture about how they think about stuff than most other people. For you, and I move on to another philosopher, Karl Popper. He spent most of his life in London. And I think his thinking is quite natural to most of you. You can only be proven wrong. If you have an idea, you cannot prove you're right. It just works until you've got some evidence it doesn't work. And that's very much at the heart of how statistics work. You start with a hypothesis. If the data doesn't tell you it's bollocks, you believe it's true for the time being. And most people don't think like this. They really don't. They think they know the answer. And then they're quite surprised if the data tells them it's different. Or to put it more bluntly, and here's the share price of Lehman Brothers, you make money until you don't. And I tell you this as well because in the context of Lloyds, for which I work, and that's insurance. Insurance is as well quite an interesting business model because we don't sell products, we don't sell any gadgets where we know how much it costs to produce it and we try to sell it for a little bit more. But we sell promises. We sell the promise to pay for future claims for an upfront received premium. We don't know when or how much we have to pay. So in that sense, we're a bit more like the church. Pray now, and heaven will await you later. So that means as well, in insurance, you At the beginning, you set a price based on some past experience, but you don't know if that was the right price. And you make money until you don't. And for Lloyds, that was really the case. And in 2001, we lost 71% of our capital. That did hurt a little bit, as you can imagine. And so we had to change. Clearly, the data told us we can't go on like this as we did. So what happened is, from 2002 onwards, Lloyds changed its business model. And from then onwards, syndicates who trade at Lloyds have to submit a business plan every year to Lloyds, which is then reviewed and approved. And I work in the analysis team, and what we do is analyze the data we get from the syndicates and play it back to them to show them this is your performance against your peers and against your own business plan. So very much we introduce this kind of scientific thinking into the market without telling anyone. But basically, we get a business model in, an idea how to make money. And every year we play back to them, actually, either this idea seems to be reasonable, you have made money, or actually this idea doesn't seem to be sensible in the first place. You need to change. And that is quite a different way of thinking about your business, which is probably second nature to most of you, but not outside the statistics community, I believe. And I think this is really, as well as I said, I'm a mathematician, not a statistician. It was only last year when I attended the RSS conference, it became obvious that mathematicians are quite different. We start usually with some axioms, things we believe are true. We don't even question that. And then we derive. And you start with an hypothesis, which is quite different. And then you try to prove it's wrong. And if you can't do that, you think it's reasonable. And that's quite challenging. And here's another chap who really challenged our perception. Who has seen Hans Rosling already? Most of you. Fantastic talks, moving bubble charts, and the world has changed. And that really inspired me as well to take the same technology and use it to engage with my colleagues. At Lloyds, we published a wonderful book. It's called The Statistics Rating to Lloyds. It's about 300 pages of tables. Exciting, huh? Well, when I went to see my communications department, I said, here, look at this book, 300 pages of tables. Could you help me to promote it? Well, it wasn't really that exciting for them. So I thought maybe I can use the technology Hans has used as well. And I was quite fortunate. Google had, I think, bought the IP of Hans and developed something they called motion charts. And I wrote a little plugin for R, or a package as we call it, as an interface between the Google motion charts and R. So when I've got data in R, I can just visualize this in a motion chart. So what I've got on the next slide is just that. The World Bank makes all its data available on their webs, and they've got as well a beautiful API, so you can just download the data via a command line. And this is the demo of the Google Viz package for R. And what I've got here is data, as Hans presented as well. So all the dots present different countries around the world, the colors the different regions around the world. And I've got fertility rate on the y-axis and the life expectancy on the x-axis. And what we see here is the picture in 1960. And that's probably still what most people's perception is about. We've got, so we've got, here's most of the African countries, China and India as well. They have lots of people, but they don't get that old. They die when they're in their 30s and 40s. That was the picture in 1960. Now, this is a motion chart, so I can actually play the time as things have developed. So we move on from the 1960s, and we can see how China is moving to the right. And most countries now as well, they live longer, and now we're getting into the 80s. And even now as well, the African countries have fewer and fewer children. And we're getting into today's world. So there we are in 2011. And this is quite remarkable. So we've got now most countries in this area here. So where they live over the age of 70 and have only about 2 children nowadays. And in particular, I think the movement of India and China is astonishing. China, certainly with its one-child policy. And tools like this really help as well a less numerical-minded audience to understand the change and as it happened. So in order to make change happen, we have to challenge their accepted truth, what they think is true. And that's not easy. And the truth is individual. It quite often varies by background as well. And if I speak about my own experience, working in a corporation where we have lots of different teams, they all have different views of the world, and they all require a slightly different tactic of how you approach them and how you tell your story. So I work with people in underwriting. They're very much sales people in that sense, actuaries, claims people, CAD modeling people, accountants, communications, marketing, legal, IT. And what makes them different quite often is the way they think about risk. So let's take IT as an example, because that's probably something most of you have similar experience as well. If you want to use a new software application and you go to IT and say, I've got this wonderful software application, let's call it R as an example. Can I use it? And they say, no. Not because they want to say no, just that's their first reaction, because they have to think about the risks involved. And as well, it took me a long time as well to establish why they actually said no. And in this case as well with R, was it because it was open source? Well, in the end, it wasn't because it was open source. In the end, it was just about support. In the end, they said, well, if you build something which you want to use in your production environment, we have to make sure that we can support you. Because if we apply a patch to the operating system and suddenly this stops working, we can't help you. Who can help us then? And I thought, okay, if that's the issue, if it's about risk management, we actually get to the real problem and we can solve it. So we found then a third-party provider who could actually provide us this kind of support, and we could move forward. But it's getting over the hurdle, what is actually their truth and how can we challenge them? So you have to find the best comparison. And I've got here just 3 examples which have worked for me. And I come back to IT, and this is a fantastic chart, I think, from Bruno. And it's not so much IT in the conversation with IT people, but it's when I talk to my managers or if you talk to someone who's got budget. And again, most people who have budget are not geeky. Not at all. I am a little bit. Yeah. Other people have children. Don't ask me what I do at night or what he does. So what I plot here is, on the x-axis I've got task size, and on the y-axis how much time it takes to complete this task. If you do it manually, the bigger the task, the more time it takes. Now if you're geeky like me, you start manually, and eventually you get fed up with, can't do this anymore. Copy, paste, copy, paste, copy, paste. Creates jobs, I know, copy, paste, copy, paste. But I start programming it. Eventually, it takes me a little bit longer, but eventually I've got something which is actually generic and it works across all task sizes. The challenge for me is quite often a lot of what we do in my company is around here. Yeah, where you could do it manually. And if I take Lloyds again as an example, we've got 80-odd different syndicates who trade at Lloyds, and you have to manage them. You kind of can do this in 80-odd different Word files. It does become a little bit painful. If you're a big company like Amazon or HSBC or something like that, and you have millions of customers, of course you can't do that in Word or Excel, and you have to do something else. But the challenge is quite often if you have task size which are kind of on break even, then it is often quite challenging to communicate that. And it's then to explain, okay, but over a number, because we have to do this every month, etc., etc., eventually we get economy of scale. Another example I've got here is more related to actually how we assess performance of syndicates. And I was saying earlier as well, we assess their performance and to challenge as well their business model, challenge their business plan. And what we focus on is their performance against their individual business plan, which I've got on the y-axis here, and on the x-axis their performance against their peer group. And if they're in the top right-hand corner, they're better than their business plan, better than their peer group, well, we should open a bottle of champagne. But sometimes as well, people move around in this kind of chart. And if they're in the bottom left-hand quadrant, life becomes a bit more challenging. And instead of champagne, you may get only a cup of tea.
One of those interactive charts to
Next one. Not this one here. Yes, but it very much, when I look at the data at our side, it looks more like a weather report. You can imagine, I've got lots of dots being different syndicates, and I can see over time how they're moving around. Now let's talk about interactivity again. And this is in the slide. And this is a graph which surprisingly works really well with our management and senior management. Let me explain this first, and then I'll play around a little bit. So imagine you have on the x-axis your customers, whatever they are. And on the left-hand side, you have your most profitable customer, and on the right-hand side, the least profitable customer. And what you plot then, the blue line is the cumulative profit you make. So the first customer gives you maybe 20% profit, the second maybe 5%, but I would then plot 25%, and if the third one gives you 2%, it would plot 27%. So it goes up and up and up. As you have customers which make money, eventually it gets flat. And then when it comes to the right-hand side and it comes down, those are the customers who actually cost you money. The red line is literally just the cumulative revenue share of these customers. So what this chart really helps to illustrate is quite often you have only a small proportion of customers which actually cost you money. And this is where you should spend your attention. And quite often as well you find this Pareto principle again, that 20% of your customer generate about 80% of your profit. Or in the other end as well. So in this example here, which is somewhat related to insurance, so I can see now how much customer, for instance, the top 25 profitable customers gave me, and as well how much profit. So in this case, if I go back to 25, so the top 25 most profitable customers could have generated 160% of the profit I actually made. Yeah, and up to here, we could have made nearly twice as much money as we did because of these guys who cost us money. Of course, this is here literally just an example, and I can play around with this now. So here I've got the number of simulations, kind of number of customers, and hopefully this works in the background. I can change as well the expected profitability level by customer, maybe as well the standard deviation, and as well operating expenses. And we call this a whale chart. It does look like a whale, doesn't it? And we can make the whale flip. That's not good. When it looks like this, you're not making money. So you want to avoid that. So it's just a little tool which helps people as well to understand the size of the problem. I think that's really important. What is this? How big is this problem? And in this case here, in this example, okay, we've got only a few guys who cost us a bit of money. And in this case, so there's 100 there, so we could have made 28% more money than we did. And I think this is really neat because now you can do all this, and this is now an example where I used R, I used Google Viz to create these interactive charts, and as well there's something called Shiny by guys from RStudio, which allows you to create wonderful, like this, web applications. It's quite straightforward. I mean, the whole code is maybe 50 lines, if at all. As I said, I will put these slides are actually online as well, so the code is available as well. And when you talk to them, have fun. Here's an example I found from Christopher Gendrand, and he's using D3. That seems to be the future, data-driven documents. Now, I have no idea what it means, but it is still fun. So, and again, I can just bounce around with this wonderful little graph. I think it's just beautiful. And I'm doing this in a slide, yeah? I'm not using, and I think this as well. You don't have to, you're not stuck to PowerPoint. Use something else, like this one, for example. One more time. Wonderful. Okay, that brings me kind of to the end already. So in summary, I come back to Karl Jaspers. In communication lies the origin of truth. And as I said, it's really important to recognize that everyone has a slightly different view about what the truth actually is. So talk to people. Invite them for coffee, bribe them with beer, whatever works. But make sure you have fun and have fruitful discussions. And in that sense, interactive relationship with your colleagues. And where possible, use interactive charts as well to make it all a bit more entertainment as well. Life is boring otherwise. Thank you very much.